All right, so for this question, right away, because it says the continuous function g, the derivative of f, I am going to write this down. G equals the derivative of f. All right, because that might help clarify some things that are going to try and make it confusing later on. The function g is a piecewise linear for -5 to 3. And g of x equals 2 times quantity x minus 4 quantity squared for 3 to 6. If I look at the graph of g, I can find the area under the curve all the way up until 3. And why can't we find it after 3 just by looking at the graph? Because it becomes a curve. They're not straight lines anymore, right? It's not a circle, whatever. So, if f of 1 equals 3, what's the value of f of -5? Well, how am I supposed to find that out? Well, they give you an f, they're asking about an f, and f prime equals g. So that would be the antiderivative from -5 to 1, f prime x dx equals f of 1 minus f of -5. Again, when in doubt, first fundamental theorem of calculus. That's going to help you. And why? Because it connects the derivative with the antiderivative. Now, we know that f prime is equal to g, right? So you could write it as g right here. That's fine, or leave it like this. So what is the area under the curve from -5 to 1? Well, from -5 to -2, it looks like -9, right? And then minus 1/2 for that triangle. That'd be a width of 1, height of 3. And then from -1 to 0, that's 0. And then from 0 to 1, plus 1/2, width of 1, height of 2. F of 1, they said, is 3. Now, in all honesty, guys, if you subtracted 3, then took the opposite of everything on the left side, you would get credit for this problem, right? That would be an answer that's all numeric. However, we could do a little bit better. -9 minus 3/2 plus 1 minus 3 equals -f of 5. Negative f of -5, I mean. Okay, -9 minus 3 is -12, plus 1 is -11, so it'd be -11 minus 3/2 equals -f of -5. How many halves is -11? That'd be -22. Minus 3 makes -25 halves. Take the opposite of both sides, it'd be 25 over 2 equals f of -5. Okay, let's go check the answer key here, see what they have to say about the scoring of points. You get 1 point for the integral, and you get 1 point for the answer. Now, do we have to say this? I would definitely say that. Okay, part B. Evaluate the antiderivative from 1 to 6, g of x dx. Well, if I want to find the area under the curve from 1 to 6, well, I could find the area under the curve from 1 to 3, but after 3, that's a quadratic, it's a curve. I'm not going to be able to get the exact area. They didn't say approximate the area, did they? They said evaluate the antiderivative. Well, good thing they gave us that function for g from 3 to 6. Okay. Sometimes if you're confused, remember they gave you a function for g from 3 to 6. You're gonna have to use it. So in this case, you can find the area under the curve from 1 to 3, but after 3, you have to use a function, right? Well, that means you're writing two antiderivatives. 1 to 6, g of x dx, and that would be antiderivative 1 to 3, g of x dx is fine to write, and then add on the antiderivative from 3 to 6. Oh, let's save a step and write out what it is. Right? Okay, this is number 3, so no calculator, so we have to do this ourselves. Alright, area of the curve from 1 to 3, that looks like a 2 by 2 square, so that's 4. Plus, okay, the 2 is a constant multiplier. Oh, I forgot dx up here. The 2 is a constant multiplier, put that in front, right? Then we definitely have a composite function, but the inner function is a linear function, lead coefficient 1, so we don't need to do u substitution. You can if you want to, but we don't have to. So then the antiderivative will be 2 times 1/3 x minus 4 cubed, evaluated from 3 to 6. Clean that up just a little bit. 4 plus 2/3, and then evaluate from 6 minus 4 cubed minus 3 minus 4 cubed, and then let's keep going. Would this be good enough for an answer? Yeah, funny enough, this would be. We can do better though. Okay, 2/3. Okay, 6 minus 4 is 2. 2 cubed is 8. That's -1. -1 cubed is -1. The opposite -1 is +1. That's 9 divided by 3 makes 3. 3 times 2 is 6. 6 plus 4, 10. Okay, why am I harping on you guys always about rewriting things and writing things out? Because you get a point for actually splitting the antiderivative up at 3. It says in the score, split at x equals 3. We split at x equals 3, you get a point. That takes conceptual understanding, that knowing that you can't find the area or evaluate the integral with just the area under the curve. You need the function also. You get 1 point for the correct antiderivative, and then you get 1 point for having the answer. Okay, any questions on that? Part B, part C, I mean, 4, -5 to 6 on what open intervals? So they're already telling us what our answer should look like, open intervals. If any, is the graph of f both increasing and concave up? We've done this before, right? C. Now, again, write down what you're looking for. I want f increasing. What does it mean for f to be increasing? F prime is greater than 0. I want f to be concave up. F concave up. What does that mean? F double prime greater than 0. Now I'll go find it. Okay. What is f prime? F prime is exactly g, right? So I'm going to make a note here. I'm looking for where g, which equals f prime, is greater than 0. I'm looking for when g is greater than 0. What about this one over here? G prime equals f double prime, and I want to know when that is greater than 0. I'm looking for when the slopes of the tangent line of g are greater than 0, right? Okay, so look at the graph of g. Where is g greater than 0? What do you guys got? First one, 0 to where? And then 4 to 6. Why do we have to break those up? Because 4 is at 0, right? So you can't include 0, okay? It does not say equal to 0, it says greater than 0. All right, what about g prime being greater than 0? Where are the slopes of the tangent lines greater than 0? Is that -2 to -1? Is that correct? Would that work? Where else? Where else? And now we look at the overlap between these two, right? Okay, 0 to 4, nope, I can cross that out because we got nothing negative over here. 0 to 4 overlapping with anything over here? Yeah, 0 to 1 overlaps with 0 to 4 for a while. So we got 0 to 1 for sure. Where else? 4 to 6? Okay, now this is definitely a statement writing part. F is both increasing and concave up on the open intervals (0 to 1 and 4 to 6) because, and what am I going to write for my because? What I was looking for. G, which equals F prime, is greater than 0, and G prime, which equals F double prime, was greater than 0. Done. Part D. Find the x-coordinate of each point of inflection of the graph of F. Well, for F to have a point of inflection, we need to look for the critical numbers for F double prime, right? What does F double prime equal? Equals G prime. Okay, that means we need to find the critical numbers, G prime. Where would that be at? What are the critical numbers for G? What do you guys got? Is negative 2 a critical number? Why? Sharp point, right? How about at negative 1? Yeah. But we are looking for point of inflection. They didn't really ask us what the possible points of inflection were. We don't have to note those. They want actual points of inflection. So let's do better than this. We look at the possible points of inflection and let's make a determination right there when we find one if it is a point of inflection. Well, for it to be a point of inflection, the slopes have to change, right? Change signs. So G prime would have to change signs. Now at x equals negative 2, does G prime change signs? No, it goes from 0 to positive. Is that changing from negative to positive or positive to negative? No. How about at negative 1? Definitely a point of possible point of inflection, but signs don't change. How about at 0? How about at 1? How about at 3? Then no points of inflection or what?
4.
What do you mean 4? But what's G prime? Yeah, 0. So it is a horizontal tangent line, right? Because critical numbers come for where G prime is 0 or when G prime does not exist. We only looked at G prime not existing. Now there's the G prime equals 0, right? So we do have a point of inflection at x equals 4. So we have a point of inflection at x equals 4 because F double prime, which equals F prime, changes signs, which means F changes concavity. Now, I guess I could have been a little more specific. I could have said where this is undefined or equals 0, right? That would have been helpful too, I think. But if we're looking for critical numbers, we should understand that's where the derivative is undefined or equals 0. Alrighty. Any questions on this part? Not too bad, right? Let's go to the next one. The figure above shows the graph of a piecewise linear function f. Okay, what happens if they give us the graph of just regular f? That means they're probably going to define f as an antiderivative. For -4 to 12, the function g is defined by the antiderivative from 2 to x f of t dt. What can you just about guarantee they're going to ask based on this setup? What are they going to ask about or have us do just by looking at the stem? Probably find g prime. That would make us use the second fundamental theorem of calculus. Okay, let's see what happens. Does g have a relative minimum, maximum, or neither at x equals 10? Well, by golly, to see if g has a relative minimum, you have to find g prime, don't we? So right away, we have to find g prime. And what does g prime equal? Quick? F? Using second fundamental theorem of calculus. Guess what, guys? Just by writing this down somewhere in the box, you get 1 point. Kind of nice. Now, we got to check to see what's happening at x equals 10 now, which means we have to look at what's happening with f of 10. Okay, for g to have a relative max, min, or neither, a relative extrema, that means we have to have a critical number for g, which means g prime has to be undefined or equal to 0, right? Well, g prime is f, means where is f undefined or equal to 0? Well, f is defined everywhere, so look at what's happening for f being 0. Is f of 10 0? Yeah, so 10 is a critical number. But does that make it a maximum, minimum, or neither?
Neither.
Why?
Because it doesn't change signs.
What doesn't change signs?
G prime.
Which is equal to?
F.
Okay, that's it. The g has neither a relative minimum or maximum at x equals 10. Or a minimum. I'll continue with my sloppy handwriting. You guys know what it is. G has neither a relative maximum or minimum at x equals 10 because g prime, which equals f of x, does not change signs. Now we could talk about x equals 10 is a critical number, but it doesn't change signs. The other thing you could say is that g prime, which equals f, is always negative around x equals 10. That would be okay too. That's just also saying it doesn't change signs. Okay, part B. Does the graph of g have a point of inflection x equals 10, x equals 4? Well, they're being really nice to us again because they're asking about a specific value. Well, they're talking about g again, so we need to look at g double prime for points of inflection, and that is equal to f prime. If g double prime having a critical number means f prime has a critical number, is f prime critical at x equals 4? I would say so, right? That's where the first derivative does not exist or is equal to 0. F prime at 4 does not exist. Now, does the sign change around 4. Changes from what?
Positive to negative.
Is that important though, that it changes from positive to negative? No, because that just means that'd be for like local max or min. We just are looking for a sign to change at all. So yes, does have a point of inflection. G has a point of inflection at x equals 4 because G dou prime, which equals F prime, changes signs at x equals 4, which means G changes concavity. All right, so far we've only accumulated 3 points. 1 point for writing this first one down, 1 point for the answer and reason, 1 point for the answer and reason. Okay? Part C. We haven't done a max min problem yet, have we? Until now. Find the absolute minimum value and the absolute maximum value. Well, those dirty round scoundrels making us do 2 things. Well, it doesn't really matter. We're going to have the whole chart set up anyways. Okay, it's just noting 2 different numbers now. Justify your answers. Definitely a T-chart or a candidates test. And we're looking at G. So where does G prime have a 0 or is undefined? Well, G prime is equal to F, right? Whereas G prime equal to 0 or undefined, which means F has to equal 0 because F is defined everywhere. I should say on the closed interval, -4 to 12. So let's make a candidates chart. Beginning one would be -4. That's our boundary. What's the next one?
-2.
Then what?
6. Why would you pick 2 though?
Why would you? And do you have to?
You shouldn't have to because
Why not?
it doesn't change signs. The G prime does not change signs.
I like how you fixed that. Yeah, G prime does not change signs, so could we eliminate 2 from our candidates table?
Yep. As well as 10.
Why?
Because the set plane.
It's neither a maximum nor a minimum, is it? So I like to list my candidates and then check to see if I need to get rid of any of them. What happens if you did evaluate G at 2? Nobody cares. It's going to be an answer. Okay, you can do more work if you want to. All right. Okay. So now we got to find what G of -4 is. Oh, G of -4. This is going to take a little bit of work. That's fine. We know how to work. We're from North Dakota. We know how to work. 2, -4. Some of us know how to work. F of t dt equals, well, I know there's a problem there, so -4 to 2, F of t dt. Okay, find the area under the curve of F from -4 to 2. Well, -4 to -2, that looks like -4, right? From -2 to 2, that looks like 8, but I forgot to put the negative out in front. So that would be 4, and then the opposite of 4 is -4. Now I did the math in my head. I want 1/2 of 2 times 4 to find this at value. I want 1/2 of 4 times 4 to get that value. You can write it off if you want to. I chose not to for this one. Okay, let's go find G of -2. And that would be, are you okay if I go -2 to 2 and put a negative in front right away? Is that cool? You see why that's legal? And then the area under the curve from -2 to +2, I just told you it was 8, so take the opposite of 8 would be -8. And the g of -2 is -8. Looks like we have a candidate for the minimum. Maybe, I don't know. G of 6. Antiderivative 2 to 6. Oh, because after 2, things are going in order then, right? You're just looking at the graph from left to right now. After 2, we don't need to switch things, so we're not walking the graph backwards, accumulating the opposite of the area as if you would walking left to right. From 2 to 6 then, what is that? Is that 8? Fun fact, kids, what is the area under the curve at x equals 2? What is g of 2, I should say?
Zero.
Yeah, 0. Right? So, we could figure out if we needed to. G of 12 then. So here's the deal, guys. After 6, what's happening then after 6? We have that graph. This is 2, right? This is 6. What's happening after 6? If we go 2 to 6, we get 8. What's happening after 6? Is the number getting bigger or smaller? Smaller. Why? Adding on negative areas, right? So this would cancel out this, and this is -4. We can clearly see we have a maximum of 8 at 6. We have a minimum of -8 at x equals -2. Let's just state that and be done. So G has a absolute maximum of 8 at x equals, what was it? 6. G has a absolute minimum of -8 at x equals -2. Done. This problem is 4 points, guys. Make some money. For -4 to 12, inclusive, find all intervals for which g is less than or equal to 0. So we have to include when it is 0. That means we might have to use brackets. How am I supposed to do this? Well, didn't we just make a t-chart with values for g? Where is g negative? Well, it's certainly negative here. How about here? It's negative all the way up until 2, that's 0. And then after that, g is positive for a while until then it becomes negative again. So I know the first interval from -4 to 2. Now, at what value then does g start becoming negative again. Well, right here, G is 0, right? G is positive, G is positive. G is less positive, less positive, less positive, less positive. And now, right here, because this area cancels this area, G is 0, right? And now after that, G is negative. So that means from 10 to 12. And that is good enough for me. That's how I would figure it out. G would be negative, or the accumulation of the area would be negative. The problem is you start at 2, you work backwards. So if you start here and work backwards, that means this is actually negative. Then you start adding an opposite of negative, but it doesn't get any past, it doesn't become more positive. This does not overtake this much. Okay, start here and move this way, positive, 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 less positive to 0. Now we're negative. And that's what they want you to do. Okay? Any other questions on this one? Another packet bites the dust, kids.